Replication packages in software engineering secondary studies, a systematic mapping. What this means, this is a study done by the University of Helsinki in Finland and Dalhousie, Halifax, Canada. Oh, Canada. So they tried to look back on studies published between 2013 and 2023. These studies are software studies. So any study that was related to the programming space, whether it was about languages, programming languages, paradigms, bugs, GitHub repositories, you name it, there's all kinds of stuff in there. And they found that only 25.4% of the studies include replication packages. So a quarter of all studies from 2013 to 2023 have a replication package. Now, the slightly good news is that in 2023, half of the studies provided a replication package, but a lower percentage, 29%, used a permanent repository with a digital object identifier. That's what the DOI is. If you ever read any of these scientific papers, you'll note that a lot of them are tagged with a DOI dot some kind of verbiage after that. And the reason why is that they are identifying a particular storage, and that storage includes information related to that study. And it could be the data sets used to come to the conclusions that they did. It could be references to other studies, etc., etc. Like there's all kinds of stuff that goes into that. So we have a big problem here. The problem is that we cannot replicate the software studies that we have, at least a quarter, maybe up to 50%, depending on how you look at this, that we've done from 2013 to 2023. Why is this the problem in the scientific field? This is from the NIH, which is one source of definition for the scientific method. Replication is one of the key ways scientists build confidence in the scientific merit of results. When the result from one study is found to be consistent by another study, it is more likely to represent a reliable claim to new knowledge. Reproducibility or replicability in science is one of the key fundamental cornerstones of the scientific method. If you are basing a study or the conclusion of a study on a set of data or mechanisms that you've defined within the study, and it is accurate, then other people should be able to take that study and replicate everything that you did, and maybe they might come to different conclusions, but at the very least, they can replicate at least the process. If we can't do that in software, then we have a big problem, because all the conclusions that come out of scientific studies in software means that we have a moving target. We're never nailed down on what's happening in the technical field with a science behind the reasons why we do things or the conclusions we make with the things that we do in software, programming, hardware, all of it. You can even see the journals that they went through. And some of these journals cover more than just software engineering, but they honed in on software engineering in particular, usually because software engineering is easier to replicate than hardware studies, because you still have to have access to the hardware to replicate the hardware study, whereas software is a bit easier to get your hands on. But even still, you can see some of the replication package availabilities. For example, information in software technology has a high no percentage of no package availability. You can see the IEEE, which is used quite a bit. 50% yes and no. So the conclusions that come out of these, and therefore the decisions that come along with them, are at risk of never being nailed down to anything, because how do you replicate it? How do you reproduce the study? This is one of the biggest problems I think we have in tech, and in particularly programming with software, websites, video games, etc. This is why I think a lot of arguments devolve or reduce down to, but my feelings though, but my preferences though, but the stuff that I experience though, because we actually don't have good studies in mass to confirm the way that we think things should operate. That's why I'm often relegated to having to try and make purely logical arguments. We have a space, the programming space, which should operate in a closed loop system. It's an enclosed system. It's inputs and outputs. And you can look at that system and see that it is operating on nothing but logical sequences. So most of my arguments have to be reduced to that, which is sometimes a very difficult position to take, because we don't have the scientific data to back up a lot of what we're saying. And so the people who do not actually understand what programming is will overlook the fact that logic is the domain that tech exists in, and they will instead use, but my preferences though, but my feelings though, but my developer experience though. And there's very little hard data to anchor all of those things to. Anyway, this is a problem, and then LLMs will not make this better.